Hey everybody, Mr. Bowman here. In this video, we are looking at 2.13 simulations. This is a probability related topic. We're looking at the Smith family 2022 holiday. So the Smith family would like to go on a weekend break once a month over the 6 warmer months, November through to April. Sometimes they can't get away due to the weather or cost, and the Smith family can go away for one holiday per month. So a lot of information in that paragraph. I think 6 is going to be quite important. And maybe for those of us aiming for merit and excellence, the weather part and the cost part might also be quite relevant. Once a month, there is a 50% chance they'll go away on a family holiday. So that's what they're talking about, how many times they can go away. There's a 10% chance they'll visit friends. That's not a holiday. 10% chance they'll go somewhere new. That's not a holiday either. And then there's a 30% chance that the family doesn't go on a holiday at all that month. So they don't do anything there. Design and carry out a simulation that allows you to estimate the average number of times per year the Smith family will go away and the probability that they'll spend exactly 4 holidays in the 6-month cycle. So your report should follow the TTRCA process. So let's start off with the first T, I suppose. So that there is tools, and let's bold and underline that. So tools, just a reminder, you don't need to write them in paragraphs if you don't want to, but you can bullet point them. I personally would be bullet pointing them. So the first thing we need to do is we just want to describe what tool that we're going to use. And in this case here, I've got the graphics calculator or a calculator ready to go. So we're just going to say, I will use the random number generator on my calculator to generate numbers between 1 and 10. So just a note, I'm using between 1 and 10 because the percentages I had here, 50%, 10%, 10%, 30%, they are all percentages of 10, so they are 1/10. So that means I need 10 numbers for those. So the next bit here, I'm going to change the pen color or the typing color because this here is actually a merit requirement. Just stating the formula. I will generate these random numbers by using the formula random int hashtag, was the hashtag 3, 1, 10. So I've stated the formula. So that's actually a merit criteria, which is really cool. So let's go back to red, back to the achieve stuff. And we're now going to talk about the number allocation. So for my simulation, so 50% represents 5 of the numbers. So 1, 2, 3, 4, and 5 will represent the family going away on or going away to their holiday home. The next numbers, so the next one is a 10% chance, so that will be one of the 10 numbers going to visit friends. So 6 will represent visiting friends. Again, the next number is also 10%. You can see it over there, 10% chance of going somewhere new. So 7 will represent going somewhere new. And then finally, the last 30%, they don't really do anything that month. So that's the last 3 numbers. So 8, 9, and 10 will represent not going away that month. Okay, so that's the achieve part there. We can actually really easily change that last bit to some merit criteria just by adding in a bit of a blue. So let's change to the font colors. So because this has a probability of 50%. So all I'm doing is I'm just linking in the probability of each of them. So I'm just going to copy and paste that. So that one there was 10%. Same with this one. That one was also 10%. And finally, this one here was 30%. So the red stuff, 100% you need them for achieved. The blue stuff, a bit optional, don't necessarily need them in this particular question. So let's get back to the red one. This one will be a bit annoying because I'll be chopping and changing between the two. So we're going to now look at trials. And same thing, let's get into some bullet points. And trials is where we describe what's happening. So the first obvious one is we will conduct 20 trials, or whatever it may be. Your teacher may have told you to do a different amount, and that's just an achieved criteria. We're then going to start talking, well, what does each trial represent? And this is when we maybe start thinking of a trial as an example. I'll delete this all later, but an example is we're representing 6 months of the year, and every month we're trying to decide if the family goes on a holiday. So we're going to be generating a number that represents month 1, a number that will represent month 2, and so on, and month 6. So we're going to be generating 6 different numbers. Each number is going to relate to whether or not the family goes on a holiday during that month. And then from that, we can decide how many holidays they go on in a given month. So let's see how we can describe that. So each trial will include 6 random numbers, which were generated, each number representing a month in the warmer part of the year, and the holiday outcome for that month. So I've got that there. We're now thinking, what else do we need to add in? The final thing, particularly for achieved, is we need to be very, very clear. When does the trial stop? So the trial stops, and we're going to carry on, say when that trial stops. In this case, it's a nice easy one. It's going to stop when there are 6 numbers that are generated. This trial stops when 6 random numbers have been generated. Okay, now for merit, so let's change to the blue. For merit, you could think about describing what a successful trial is. So a successful trial is, and we need to figure out that, and an unsuccessful trial is. So we just need to figure out what exactly a successful and unsuccessful trial is. The question will tell you that, so let's go back up to the question. And it relates to this last bit. So the probability that the Smith family will get exactly 4 weekend holiday breaks. So I'm assuming that relates to them going to the holiday home, because the rest we're not really sure if they count as holiday breaks. So will they get 4 of them in a month? So a successful trial is when there are 4 numbers between 1 and 5. That is, the family goes to the holiday home exactly 4 times in the warmer months. So that's a successful trial. Any other number, 0, 1, 2, 3, 5, and 6, holiday home visits, that's an unsuccessful trial, is when there are 0, 1, 2, 3. I'm missing 4, so 4's gone, 5 or 6 holiday home visits. So that's going a little bit extra. That's why that counts as the merit stuff. So let's change back to the red one. So those are trial section, which is really cool. So that makes it a bit easier. Now the results, this is where it's going to be a little bit, I suppose, different. So trial number 1. Let's just do 1. And what we're going to do is I'm going to show you how to do maybe the first 5 together, and then we'll skip ahead, and I won't do them all with you. So if you're using this calculator, your calculator might be slightly differently. We're going to go into the regular calculation mode. We're going to go to options. We're going to go across. So don't forget these little buttons here on the screen relate to the F buttons. So we're going to go across F6. We've got probability, which is F3. Random number functions are all in here. And this one here is going to be a little bit different to some of the ones you use. So we've got the random number. We're going to times that by 10, and we're going to plus 1. So if you're not sure how to get your calculator to work, please make sure you ask your teacher. And you can see when I start pushing the numbers, I've got a whole bunch of numbers coming up. And the key thing I want to note is the way we've done the formula, we're ignoring all the decimals, and we're only focusing on the number bits here. So what I actually just realized, I should go ahead and change my beginning bit, because you see the formula right before, that's based on a different calculator. So let's update that for R1. So random number, it's going to be times 10 plus 1. And we should note we will ignore any decimal parts of our numbers, just to make that super clear for anyone else who might want to do what we're doing here. So now that we've done that, I had a bit of a glitch there. Let's actually do some trials. So we've got some numbers generated already. So that was 9, 5, 4, 3. Let's generate 2 more numbers. 1, 2. We got 6 and 1. 6, 1. I'm going to unbold and underline these. Okay. So we now need to figure out how many trials, how many holiday homes did we have? So don't forget, those were numbers between 1 and 5. So we can see we got 5, 4, 3, and 1. So straight away, we've actually got success. 4 holiday homes. We'll just write 4 holidays, which means this is a success. So let's do the same. Let's generate 6 more numbers. So 1, 2, 3, 4, 5, 6. And we can ignore the 1 because that was at the end of the previous one. So we've got 4, 3, 6, 3, 9, 3. So again, let's check how many numbers between 1 and 5. And again, I think we've got a success. We've got 4, 3, 3, 3. So we've got 4 holidays. So this is more than my previous trial that I did, because I only had 2 already. So let's generate 6 more numbers. And again, noting the 3 is the last one, so we can ignore that 3. 1, 2, 3, 4, 5, 6. There we go. So ignore the 3, and we've got the rest here. We've got 6, 5, 4, 1, 8, and 7. I've just realized we've got them in the wrong heading there. Let's bring them back up there. So how many holidays is that? It would only be 3 holidays. So these ones here all would be a holiday, the others wouldn't be. So this one here, 3 holidays, and this is an unsuccessful trial. I've spelled successful, had a nightmare doing that. So that there's unsuccessful. So let's do 2 more together, and then we'll just use those numbers, but in the real internal, you should be doing 20. So let's generate 6 more numbers. 1, 2, 3, 4, 5, 6. So again, we're going to ignore the 7 up the top there, because that was the 7 from the end of the previous trial. So we've got 10, 2, 7, 9, 6, and 8. And that, let's see how many holidays it is. So just the 2, so only 1 holiday there. So not many holidays, so 1 holiday. And again, just like before, that's an unsuccessful trial. I'm writing out success and unsuccess, or successful, I should write successful and unsuccessful. In the internal, feel free to do more like a tick and a cross type scenario. So let's do 1 more trial together. So again, we're at the H, but let's generate more numbers. We've got 1, 2, 3, 4, 5, 6. So ignoring the H, we've got 3, 7, 7, 5, 10, and 4. How many holidays did they do? They went on 3 holidays by the looks of it. 3, 5, 4. So 3 holidays. But again, unsuccessful again. Okay, so off the recording, I've done all the trials. You see I've done all 20. We did the first 5 together, but hopefully you can see how it works. But having a quick check, we can see we ended up with 1, 2, 3, 4, 5 successful trials with 4 holidays. There was one really sad summer where they went on 0 holidays, a few 1s scattered there, and a lot of 2s and 3s. No 5s and 6s, which I happened to have in my other trials that I did the last time I did this task. But there we go, that's how it goes. So we've done the results. There's no real merit stuff to add in the results section. We're now looking at the calculations part of it. Calculations. So scrolling up, the question's really clear about what it's asking you to calculate. And if you look at this paragraph over here, design and carry out blah, 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 estimate the average. So we need to find the mean or the average and the probability. So there's two things we needed to calculate here. So let's start off with the probability because that's the nicest one. Probability of going on exactly 4 holidays. In our case, that was 5/20, which is 0.25 because that's 1/4. The average number of holidays, this one's going to be a bit more annoying. What we're going to need to do is we're going to need to add up all of these numbers and then we need to divide it by 20, which I'll do off camera. So looking at the calculator, I've added them all together. That got me to 71. 71 divided by 20, because there's 20 bits of data here, 3.55. So let's do 71 over 20 equals 3.55. Okay, so we've got all that. I'm just going to change to the blue pen color because there are actually a few changes that I want to make. So the first thing I want to do is I want to add in the word estimate in front of this here. So that's the estimated probability, and that's because these aren't the exact ones. We don't actually know what the exact ones are going to be. We're just estimating based off our simulation. So your mates who've done this task as well, they will have different estimates because of it. We also want to explain a bit more about what this estimate means and why maybe we shouldn't rely on it too much. So the calculations, which are the two above, from this simulation should be used with caution. And that's because they're estimates. They're not exact. They are estimates and are likely to be different. Oh, forgive me as I spell that wrong. Likely to be different if the simulation is repeated again. So that just tells us it's estimates. We mustn't, this isn't like 100% accurate. That's going to be the case. We must use this with caution. So let's get back to our red one. So nice little blue stuff there we can add on for merit. So we're now looking at the analysis section. And this is where I'm just going to go straight to blue. This is where the good stuff comes into play. So if you can write down one analysis, that's going to get you merit. If you can write down two analysis and link it to probabilities, that's how you're going to get to the excellence part. So for me, the easiest assumption that anyone can make is relation to independence. So we're looking at holidays for a month. For example, if we look at the last one, do you see how the first 5 of them, there were no holidays at all there? So if you had no holidays at all on during this 6-week period, or this 6-month period, I personally think the last month, your last opportunity to go on away on a holiday, I think the probability of that's actually going to be a lot higher than 50% because if you don't do it now, you're going to miss out on it for the whole year. So I think you would almost always go away on that holiday. So that means the probability of the previous ones would have impacted the probability of the last one. So that maybe means they might not be independent. So because we're dealing with random numbers, we're assuming that everything is independent of each other. But that, as I said, that might not be the case. So it is assumed that the monthly holidays are independent from each other. So we've assumed that, but that's not always going to be the case. So I'll just write 1 here. So the next step is, how does that differ in the real world? So I always say in the real world, and then ... We need to explain why that's different. And then the example we looked at before is a really good one. In the real world, this assumption may not always be true. If the Smiths go on holiday for the first 3 months of the 6-month period, then they may become less likely to go on holiday in the subsequent months. So this is kind of the opposite of what we just talked about. So we talked about, well, the first 5 here means it's going to be really likely that they go on holiday there. Here we're talking about a different scenario where maybe they go on lots of holidays early on. That might mean they're less likely to go on holiday later on. So this means the probability of going on holiday, based on the above example, may be less than the 50%. This, in turn, might reduce the probability of going on exactly 4 holidays. So what we've done is we've stated the assumption, we've explained why it's wrong in the real world, and we've chatted about how it's going to impact the probability as well. We should also actually mention we calculated the average. How is it going to impact the average? Well, it might mean the average is slightly lower than it otherwise would have been. This also means the average number of holidays in the 6-month period might be slightly lower than the estimated 3.55. So that's our first one. So if you just wrote the assumption, that's your merit, just the one. If you can do the process here that we've done twice, that's how you get an excellence. So let's actually change this here to green, because explaining why it's wrong in the real world and how it impacts the calculations, and stating the second assumption is actually how we can shift it up to different levels. So the other assumptions that are less that are actually more obvious are actually given to us by the question. So they've said they can't get away at all due to the weather and the cost. I emphasized that before. So for me, I'll be writing some assumptions about these. I'd write one about the weather, and then 3, I'd write one about the cost. Even though it's suggested you do 2, you do 2 to get excellence, do 3 because the marker might not always agree with 1. So the first one, we're chatting about the weather. So it is assumed that the weather conditions are typical for the 6-month period. Because if it's typical weather, then you'd go away as much as you normally would. However, if it's a really, really good summer, going to the holiday home, that might increase. If it's a really, really bad summer, going to the holiday home might drop down. So in the real world, there may be so what might there be? So there might be adverse weather. Might be adverse weather conditions that impact whether or not the family goes to the holiday home. So that's quite a short one compared to the previous one. So talking about how that impacts the probability, this means the probability of, maybe let's give an example. So if there were similar weather events to January 2023, so we all remember those, it was very, very rainy, the probability of going to the holiday home may reduce, or may reduce. We'll stick with that. This means, like above, this means the probability of going on exactly 4 holidays will decline. This also means the average number of holidays in the 6-month period will, or should also decline. There we go. So we've got our third or our second assumption, and again we're in green because this is the excellence one. And another one, I won't write this out fully for us, but they specifically mentioned cost. So we're assuming that the family has how do I describe this? They've got the usual amount of money that they've got. There's no barrier to going out on a cost, because in theory they could have gone for 5 or 6 holidays in the month. That would have been really, really, really expensive. Also, conversely, it might actually be cheaper for them to go to the holiday home because they already own the home. It won't cost them anything. So maybe they do that more instead of going out. So chatting about a third assumption would be recommended. And here I think going about cost would be another one. If you are looking for some other ideas, holiday home relies on travel. So there might be some travel restrictions. So we're probably assuming that there's no travel. So let's go. No cost barriers is what we're assuming there. No travel restrictions. For example, COVID lockdowns would have limited travel. The state of emergency related to the floods would have been travel restrictions as well. So there's a few other things that you might have wanted to talk about to wrap that up. So this wraps up our Smith's family holiday answer. So 25-minute video, not too bad. You'll have a lot more time to do that than I did. Just a reminder, the red stuff is the achieve stuff. They're non-negotiable. Don't miss the achieve stuff. The blue stuff was merit. Make sure you add these. I think getting merit is quite straightforward for this one. And the green stuff, this is tricky. Some people really struggle to come up with assumptions. It's a very difficult thing to teach from my perspective. But hopefully with practice and with some mahi and thinking about the scenario, you'll be able to get some good assumptions there as well. And the key thing is the assumption by itself isn't enough. You should be explaining how it impacts the estimates that you've done. So how it's going to impact your calculations up here. So thanks so much for watching. Good luck for the internal and get in heaps of practice.